Hi everyone, this week we are continuing our discussion of t-tests. So we're going to add on a new kind of t-test, but first let's look back at what we've done. So remember, with t-tests, we are generally asking, is this group different from another group? When we start to define what groups we're talking about, that is how we decide between these three t-tests. If we have a sample of data, say we run 100 people, we have a sample mean, we want to compare against a population, we're going to be using a one sample t-test. If, on the other hand, we have two separate groups of people, so I flip a coin and everyone that gets heads goes into group A, flip a coin, everyone that gets tails goes into group B, we expose these groups to two different levels of an independent variable. Perhaps we're looking at treating depression. Group A gets the treatment of maybe a drug treatment, so they get Prozac. Group B is going to get Prozac plus talk therapy. So we have two independent groups here, and we're interested in how those variables, so that treatment variable, how that influences their depression symptoms. So two separate groups, both measured on the same dependent variable. We're looking at an independent samples t-test, two independent samples t-test situation. Say now that we're interested in the effect of tutoring sessions on student grades. So we give a quiz, and then we put students through a tutoring program, and then we give them another quiz. We might call it a pre-test and a post-test. So here we have the same group of students participating before and after. Typically, this is going to be a paired samples t-test. There are different ways to run these, to set up the research design for these, but I think the easiest to discuss is this post design. So if we, for example, many of you took research methods or are taking research methods from myself or another of the psychology faculty. In your first week of that class, you take a pretest. So we're assessing your research methods knowledge before you take the class, essentially. And then during the last week of class, you take the same quiz again, assessing your research knowledge. So you end up with a pre-test score and a post-test score. So the idea is to demonstrate that we have taught you something in the course, right? So we would use a paired samples t-test to investigate that. No matter which kind of t-test you use, they're all going to be very similar in their calculation. So it's going to look at the difference between groups over the difference within. So remember, between groups depends on how you define your groups. If it's one sample in a population, it's going to be the difference between that. If it's the difference between a group on Prozac and a group on Prozac and talk therapy, it will be the difference between their mean depression scores. If you're looking at a paired samples t-test, it'll be the difference between your pre and post scores. So it's still conceptually the same thing here. It's going to be the difference between the groups, however you define those groups. The difference within groups is also very similar. So that's the individual variability, right? Because no two people will react the exact same way. So we have to control for, and that's why we divide, because we control for things by dividing. We have to control for this difference within groups. So all t-tests are going to be this generic difference between over the difference within. That gives you a t-statistic that you can then find a p-value, and you can decide if that probability is less than 0.05, right? So we're talking about distributions here. So we want our t-statistic to fall in the outside, more extreme than that rejection region. All of that stuff is exactly the same. What changes is how exactly we calculate these, because we do have slightly different situations. So here is the formula for our paired samples t-test here. So here we have, sorry, let me grab a different color here. We have our paired t equals md, so this is the mean difference. So if you're in a pre-post situation, it could be the difference between your pre and post test scores. If you're doing matched pairs, it would be the difference between those matched pairs. And then we have minus this population difference or the expected difference. Now, this gets into directional versus non-directional hypotheses. Typically in this class, this value is going to equal 0. So you'll see me ignoring this part quite a bit. So what are we left with? The difference between groups. So we have the mean difference here. This is over the SMD. So the SMD is the standard error of difference scores. So standard error of difference scores. So it's not going to be readily apparent just yet, but promise that is the difference within groups. So we're looking at the same exact thing, the difference between over the difference within. Now, to find the standard error of difference scores, we have several steps. So this gets to be a little bit tedious here. Let me fix this real quick. I made a mistake in my formula there. So we want to find this standard error of the difference scores right here. Here is our formula to do that. So to find the standard error of difference scores, we have to find the SD. So the SD is going to be the sample variance of those different scores over the square root of the number of different scores. Now this is where it gets really tedious. We have to calculate this SD. So here's the formula for that in the squared version, so we'll just take the square root to get there. But S squared D equals our good friend, the sum of squares, so we remember those, over the number of different scores minus 1. This variance formula should look very, very similar to you, right? And then we have another calculation that we have to do, sum of squares, because it's slightly different here because we're dealing with different scores. So the sum of the different scores squared minus the sum of the different scores squared. So those are different. We'll talk about those in a second. And then this one is over the number of different scores. So this, to get to this statistic here, that paired t statistic, is going to be quite tedious. So we're going to try something a little bit different, and you guys can let me know later if it helps or if it hurts. So let me pull up. I've created an Excel document for you, and hopefully you can see this. Again, I will pause here and I'll link to it. Please take the second, download this, and maybe just look at it. You know, you can do half your screen this, half the screen my video, whatever you need to do. Some people have complained that they can't see what's going on in these. That's why I give you links to them, so please take a second and download that. Now down here you have a couple of different sheets. So this is a workbook, and you have 4 sheets in this workbook. Now I've given you the formulae that you will need here. There was a comment in the review session that my formula are a little bit different than what the textbook has given you. The reason I'm doing that, I'm trying to make this as simple as possible. Maybe that's making things worse for you. If so, let me know. But I'm trying to stay around that idea of sum of squares. So whenever I can pull in those sums of squares, because I think we all conceptually get that. And if we can see that, you know, well, the sum of squares are in the denominator, so it's really just the difference within the groups, right? That's what I'm trying to go for here. So anyway, I wrote all of these out. I took a picture. I inserted it here so that it would be here for you. So you don't have to search your textbook chapter. Now, what I've done here, this first worksheet, we're going to work together. So I'm going to show you what this is doing. I'm going to show you where I would like for you to enter data, what it will do when you enter data correctly. And then you have number 3. And I believe this is number 4. I didn't label this, unfortunately. But anyway, number 19 from your textbook, number 21 from your textbook. Those are 2 homework problems. We're going to try to take it step by step to see if we can make this a little bit better. So this is the example from page 304 in your textbook. So this data is in table 10.5 there. So we have 2 rows of data here. So row B, we're looking at how long students read when an instructor is present or when an instructor is absent. So we're working with kids and we're seeing, does the presence of an instructor make them read more? Then this worksheet is going to do a couple of different things for you. It's going to find your difference score for you. So it's taking present minus absent to give you your difference score, and then it is squaring that difference score. We go down below, so this should look very similar to you, just like it did, when we were doing our variance and standard deviation. So here I've summed everything from the columns, I've counted everything, and then here are the means for all of those different things. Over here in the top left, I've set this up to pull out a couple of things that you will need from your formulae. So remember, we need the sum of our difference scores, so we have that. We need the sum of the difference scores squared, so I've done that there. The sum of squared difference scores, which is 3,400. So here the difference is we're summing the difference scores and then squaring them. Here we are squaring them and then summing them. That confuses people all the time. It confuses me all the time. So I've just laid this out for you. There's no need to get caught up in all of this. Here is the number of your difference scores, and then I've given you the mean difference. So what I would like for you to do, so I've got 7 steps laid out right here in the middle, so step 1 through 7. Here is the things that I would like for you to calculate. Of course, here are the cells where I would like you to enter those answers, and then here I've given you some information about how to enter that, because if you enter the correct number, this cell will turn green. So let me just do that for you real quick. 1600 is the answer to sum of squares. We'll work that in a second, but you can see here I entered 1600 and it turned green. So if you get the correct number, this will turn green, and you know that you are ready to go. You can take that sum of squares number, plug it into this next formula, get your value here, enter that, and you can move down the line until you get to your t statistic. So one thing I've been noticing, if there are 7 steps to solve a problem, you make a mistake in step 3, you don't realize that you've made that mistake, right, until you get to the very end of your decision, and then it can be a serious pain in the neck to go back and figure out where you went wrong. So we're going to approach this a little bit differently this week as an experiment and see how it goes. What I would like for you to do in these 2 questions is calculate all of these things on paper. If you want to do work in Excel over here, that's fine. I need to see that you guys are calculating these and that you're not just sharing the answers with each other so that you can, check this off. So that is the give and take of not having, proctored exams and weekly quizzes and those kinds of things. Show your work so that I know that you did the work, right? So do that for me. You can insert a picture here like I've done. If you just want to calculate it out in Excel, if you feel savvy enough to do that, that's fine too, as long as it's clear what you're doing. I'm happy to accommodate that. So these yellow boxes here, right here, and down here are where you will input your answers. So let's go to the top real quick, right? So we have a set of 8 children. We're observing them under 2 different time periods. During one time period, the instructor, their teacher, is in the room with them. In a different time period, the instructor is not in the room. And we record how long these 8 students take to read a book or, whatever they happen to be doing. So we have 2 two different times that we're observing the same people. So these are related samples, they're paired samples, so we need to calculate that statistic using this formula right here, the mean difference over the standard error of the mean difference. Now, you could see here we have to calculate the SMD. To calculate the SMD, we have to calculate the SD to get there. Here's that formula. We also have to calculate the sum of squares. So let's start at the very bottom there, sum of squares. I've given you a hint there. Step 1, calculate the sum of squares, right? So let's go ahead and do that. So we have the sum of squares. The sum of squares equals ED squared minus ED squared over the number of difference scores. Now, I have this worked out so I don't have to go back and forth with the Excel document. What I recommend is that you have this Excel document open and then maybe work this out on paper, or if you have two screens, that works really well too for people. So we know our sum of difference scores is going to be 3,400. So maybe I'll go ahead and pull that up real quick. So this ED squared, we know ED squared is 3,400. It is right here for us. All we're doing is taking this information that I've given you and plugging it into the formula. So ED squared is 3,400, and then we have ED squared, this one, so 14,4. So ED squared, this one right here, is going to be, well, really it's 120 squared. So here we have, let me show you real quick, we have the difference scores, the sum of difference scores, and we're going to square that. So the sum of difference scores is 120. I've pulled that right here. See, the sum of difference scores is 120, and then we're squaring the sum of difference scores, and that's how we get that number for you. So that's going to be 14, so I'm going to mark that out, 14400. We're going to divide that by the number of difference scores. So I told you earlier there are 8 students, so there are 8 difference scores. Now we have to simplify that, so we come up with 3,400 minus 14400. So I'm just going to do this on my cell phone here. I apologize, you're not going to be able to see that. 14400 divided by 8 is going to be 1,800. So 3,400 minus 1,800 is 1,600. So we know that our sum of squares equal 1,600. So when you get to this point, what I would like for you to do is take a second and enter that into the Excel spreadsheet to see if you are on the right track. Now, sum of squares equals, here's your yellow box. I've asked you to take it to 2 decimals, 1600.00. If this number is correct, it will turn green. So if I hit enter there, so we know our sum of squares is correct. If we had typed 1,500 there, it would not change that coloring. We would know it was incorrect, but of course we know our sum of squares is 1,600. Okay, so now we have our sum of squares. We can move on to that next formula that we need. So we started here with sum of squares. We're going to go backwards, and now we can look at this sample variance, or the variance of these different scores. So I've copied that down right here. So the sample variance is going to be sum of squares over the number of different scores minus 1. You can also express that as the degrees of freedom. Either way, it's going to be our sum of squares, which is 1,600, over the number of different scores. So remember, that's 8 minus 1. Simplify that to 7. So it's going to be 1,600 over 7. So I'm just going to do that on my cell phone real quick. 1,600 over 7, 228.5714. Okay, so we have the variance there, 228.5714, 228.5714, so we'll round that to 57, hit enter, and we know that we have correctly calculated that sample variance. Now, we need to take the square root to get to the standard deviation of those different scores. So we know s squared p, if we take the square root of that, we'll get SP, right? So we just take the square root of 228.5714. If we cut that off to a 5.7, we'll get a little bit different. So I would encourage you to go ahead and take that out to 4 decimals. Again, I'm not going to count off for that kind of thing, but it is best practice, and I know our TA, our course assistant, has mentioned that to you all. So the square root, so let's do SD. Sorry, I keep doing SP, but it should be SD there, because we're talking about different scores. Old habits die hard. So SD squared. So SD equals the square root of 228.5714, and I get 15.1186. Now, go back to your Excel sheet, take a break, and enter that in. I've asked for 4 decimals, 15.1186. All right, so we've got our standard deviation of our difference scores. Our next step is to calculate SMD. We're getting pretty close here. So we have done this one. So we found our standard, our sum of squares, we did that. We looked at our variance, we did that. We took the square root of that to get this number right here, and now we can get that standard error of the difference score. So let's do that. So SMD, standard error of those difference scores, is going to be just lost this. It's going to be SD, so we just calculated that, over the square root of the number of difference scores. So we know SD is 15.1186 over the square root. Remember, there were 8 children, so over the square root of 8. And to save us some time, I'll jump ahead. This is 5.3452, not another decimal there. So what I did, took the square root of 8, divided 15 by that, and we got 5.3452 for the standard error of those difference scores. Again, I'd like you to take a second, enter this. I've asked for 4 decimals, so SMD 5.3452, hit enter. We have calculated that correctly. Let's go back to our work. So we know T. So we're on our last step here. So far, so good. So we know our T is going to be our mean difference over the standard error of those mean differences. So we know it's going to be something over 5.3452. Now, where are those mean differences? I've given you those. So MD 15. So we took our difference scores, and that is the average of our difference scores. So our mean of difference scores is 15. Go back to our work. So we have 15. It's the mean of our difference score. So remember, it was we take the observation group minus the other group, and we get our difference scores, and then we took the sum of that, the n, to find x bar, right? So that's how we got there, just in case you forgot there. We have the mean of our difference scores, 15, over the standard error of our difference scores there. So 15 over 5.34 is going to be 2.9 2.806. So that is our t obtained. So remember, now we're going to compare that against our t critical. Now I don't really care for you guys to waste time looking these up in the back of your book, so I've given that to you. Let's check our t statistic, and then I'll show you the t critical there. So I've asked for 2 decimals here, so 2.81, and that's correct. The t critical is okay, so I've somehow erased it off of here. So with degrees of freedom, so we know we have 8 observations minus 1 is going to be 7 degrees of freedom. Let me look in the back of my book real quick since I messed this up. Degrees of freedom is 7 with a p of 0.05, 2.365. 2.365. Okay, good, that is correct. So then we have to decide, can we reject or do we fail to reject? So if you need to, you can draw out our good friend that I still can't seem to draw very well. -2, -1, 0, 1, 2. We know that our t critical is 2.365, 2.365, so it'll be somewhere right here. We know 2.8 is going to be somewhere like right here, right? So anything beyond, I said it was, this was our t critical, right? So anything in this range would be rejected. Our number is going to be somewhere like right here. So we can, in fact, reject the null here. So here for our decision, we will type one of 2 words, reject or retain. So reject, make sure we spell it correctly. We get the green light, we are good to move forward. Now we can calculate Cohen's d. So remember, we calculate this t statistic, we get a p-value that tells us yes or no, are the 2 groups different. That does not tell us, however, how different they are. Effect size tells us that. So the effect size we've been using lately is Cohen's, so this is a guy's name, Cohen's d. Cohen's d in this situation is going to be our mean difference, again that's a d, can't seem to draw d's here, over our SD there. So what is that going to be? We've got our SD 15.1186. We've got our mean difference of 15. So it's going to be 15 over 15.1186. We do that division. It's going to be 0.99216. We could keep going forever. We'll just round this to 2 decimals, I believe. So Cohen's d, 0.99, you get the green light and you know that that is correct. Now, I do not want us to get overly concerned with calculating numbers. That is half the battle. It feels like more than half the battle, right? Because it is so tedious, time-consuming. So what I want you to do, focusing on your decision and your effect size, just write me a summary of what is happening. Okay, so you might look at these means too. So here we can see, we know here we reject the null. Remember, the null will be that there is no difference. So we can conclude that these 2 groups are different. Based on the mean information, we can say that students read more in the presence of an instructor. So that's all I want you to do. Students read more in the presence of an instructor than they did without an instructor present. Now this one, everyone's going to use different words, so I couldn't program this to turn green for us, but I just want you to write in general what happened here. So what's going on in this situation so that I understand, or so that I can see that you understand what's going on here. So again, that's a paired samples t-test. So we have 2 two situations, we have one set of people. So in one condition, an instructor is present. In another condition, the instructor is absent. We are interested in how much time these kids spend reading in the presence or absence of an instructor. 3 hours later, we have calculated our T statistic. We've made the decision that these groups are in fact different. We could go so far as to say students read more, because the mean is 260. We know they're different. The mean is 260 than in the presence of an instructor than they do without an instructor presence. So I would like for you to calculate all of these things in yellow. They will turn green when you type in the correct answer. And then here, write out your interpretation so that I can get a sense of if you understand globally what's going on here. So that is a paired t-test, right? So we're trying to make things a little bit easier for you this week. So I've created something very similar here. Fill in these yellow spaces here. Insert a picture of your work here for number 19. Same goes for number 21. And you can see here I have in fact given you those t-criticals. So work those numbers in this worksheet and then turn in this worksheet along with the Word document of your homework. Now, in the next video, I will show you how to compute a paired samples t-test in SPSS. It is much easier. I'm not going to give you an assignment on that, however, because I do want you to focus on your midterm. So remember, please start that early. Please send it to me for feedback. And of course, if you have any questions, paired samples, t-tests, anything we've done up to this point in the course, send me an email, but also please put it in the comments that are coming up. Some people are saying that these lectures are not helping them understand at all. What's going to help me make these better is if you give me some comments about what confused you, where you got lost. So please do that in the comments box coming up.